Did you know? The speed of light isn't just about how fast light travels. You've probably heard, it's constant, unchangeable, and rules the universe. But what if that's not entirely true? What if we've misunderstood what the speed of light really means? And what if changing it doesn't just affect beams of light, but time, mass, energy, even the shape of the universe? Because you've been thinking about the speed of light all wrong. When most people think of light speed, they imagine flashlights, lasers, or starlight. But in physics, it's far more than that. The speed of light, c, is built into everything, from Einstein's equations, to the way time ticks, to the limits of communication in the universe. And the strangest part? It may not even be a speed at all. You've heard it before, light moves at 299,792,458 meters per second. But that number doesn't come from measuring light with a stopwatch. It's defined that way by how we define the meter and the second. In fact, in modern physics, the speed of light is built in. It's not measured, it defines the scale of space and time. So changing it wouldn't just make light faster or slower. It would reshape the very grid that reality runs on. Imagine you could dial the speed of light up or down. You're not just tweaking brightness. You're warping the connection between space and time. E equals mc squared, energy, mass, and light speed, would break apart. The amount of energy and matter? Changed. The lifespan of stars? Altered. Even gravity and the size of atoms would distort. This isn't just physics fiction. Some cosmologists believe light speed was different in the early universe. To explain some of the Big Bang's weird leftovers, scientists proposed something wild. That light might have moved faster in the early universe. Why? To explain why parts of the universe that should have never seen each other look identical. It's called the horizon problem, and variable light speed might solve it. If true, then light speed isn't a permanent feature of nature. It's more like a setting that once changed. Here's where your brain might melt. In modern physics, especially Einstein's relativity, light speed isn't a thing that moves. It's a limit. A ratio between space and time itself. It defines how far something without mass, like a photon, can travel per unit of time. So when people ask, what if light moved faster? What they're really asking is, what if the geometry of the universe changed? That's huge. Imagine tomorrow, the speed of light increases. Suddenly, all light-based tech behaves unpredictably. Your computer's timing fails. Fiber optics glitch. Color might shift. Even your vision, which depends on light speed delay between rods, cones, and brain, might go haywire. And in a world where light speed slowed, stars in the night sky could vanish. Not because they're gone, but because their light can't reach us anymore. Time itself might stretch. Or collapse. Here's the twist. In quantum physics, constants like the speed of light might not be absolute. They could be emergent, shaped by deeper layers of reality we haven't seen yet. In string theory, loop quantum gravity, or extra-dimensional models, C could be just a result, not a cause. Which means, it might have shifted in the past. And could shift again. But if it does, we might not even know it. Until it's too late. You've been thinking about the speed of light all wrong. It's not just about how fast photons move. It's the framework of space, time, energy, and causality. It holds the equations of physics together. It tells the universe how to behave. Change it, and you don't just get a faster beam of light. You get a different universe. Until next time, stay curious, stay critical, and never stop asking, what if the truth isn't what we thought?